little bit challenging because it was a little bit different than how we usually did it in class. So it's definitely a slightly more challenging problem, but I was pretty happy with how many people got it right. So let's just go ahead and do it together. I had a couple of people ask me why the R has a 1 and a 2. And so the reason is that these numbers, the ones underneath, the little ones, these are called subscript. And they're not really important. Like you don't use them for anything mathematical. Like you don't need to add or multiply or anything by that number. They're just there to distinguish one variable from the other. So instead of having two different variables like A or B, they just have R1 and then R2. That just means that just keeps them separate. That's all it is. So if you had a question about that, I hope that helps clarify. But then here's the thing is we're going to have to solve for R1. So if I need to solve for R1, what should I do to both sides?
Multiply by R1.
Multiply by R1. Multiply to both sides? Think about what you're trying, what are we trying to get alone?
I divided by
Trying to get R1 by alone?
Okay, so we're trying to get R1 alone, and then I heard somebody say that they divided. I didn't get a chance to see who that was.
Me.
Okay, Ilse. So what did you do? Why did you divide?
Because you're trying to get those, because wait, you can't do nothing to the parentheses, right?
Right.
So I just took the T out, so it could be, take it out of the equation thingy.
Good. So you're trying to basically get rid of the T because like the T, you don't want it there. You want it to go away. And why did you choose division?
Because parentheses means to multiply.
Exactly. So the T is multiplied by those parentheses, and the opposite of multiplication is division. So if you divide by T, that's going to cancel it out. So that was the tricky part. The way to cancel out the T was to divide it. What might you do if you didn't know you had to divide? What's the other thing your brain might have told you to do? Because you see parentheses, what would you maybe do? Anyone? When you see parentheses, usually, what do you think about when you see parentheses?
Multiplication.
Multiplication. You kind of think in your head, okay, I'm going to distribute. But in this case, we're not going to distribute because we don't want to add more things to our problem. We want to get rid of things, and we want to get rid of that T. So that's why we divided. Okay, so then I have D over T equals R1 plus R2, which means I'm almost there. I almost have R1 by itself. What's the only thing that needs to go away now?
R2.
Right, and how do I get rid of R2?
Subtract it.
Perfect. I'm going to subtract R2 on both sides. And so that's what's going to help me cancel out R2. And now I have D over T minus R2. So that's why answer choice C is the correct answer choice. And the other ones we're trying to play with your mind a little bit and make you think that it might have been a different thing. So do I have any questions on this problem from the quiz?
Let me tell you how I'm watching.
You're on a mute.
Oh
My bad, miss.
You're good. My internet is a little bit slow, so I just lost connection. Okay, there it is. It's back. Okay, cool. So while we're here talking about the quiz, let me make something very, very clear to y'all, all right? Everything in this class, every assignment, every quiz, anything I have you guys submit to me is graded, and it goes in the grade book. So if you forget to do an assignment, or you don't feel like doing it today and you just don't do it, what's that going to be in the grade book? That's going to be an F in the grade book. So I was looking at the grades this weekend and I saw quite a few Fs and Ds, And the only reason y'all are getting F's and D's is because you're getting lazy on me and you're not doing your homework. And that's just unacceptable. That is absolutely unacceptable. So going forward, I had some very nice conversations with some parents over the weekend. We talked about how we can try and make sure that we remember to do our homework. But I just wanted to see if anyone has like any suggestions. If you're really good about completing your homework, what are some suggestions you have for your classmates about what you can do to remember, to remind yourself? What are some strategies?
Learn.
Learn. What are some strategies for like remembering to do your
Probably
homework?
like do it the same day.
Okay, I saw a couple. I heard a couple. I think I saw, was that Elsie? What did you
Yeah.
say?
Do it probably like the same day, or at least do like half of it, and then you could do the other half the other day.
Yeah, so don't leave it all for the day it's due. Okay, what else?
Alarm clock.
Say that, Julia?
It's such a good
Alarm
class.
clock.
Did I say this was my
Alarm
favorite
clock,
class?
yeah. Y'all know on your phones, y'all have, there's the calendar app and then there's the alarm clock app. Set a reminder for yourself, like set an alarm that's gonna ring an hour before it's due so that if you didn't do it yet, you remember to go do it. That's another really good one. Anyone else have any strategies that they use? If you're really good about completing your homework, what do you personally do?
I don't know. I just leave the assignments up, and then I just leave my computer on so I can remember.
Okay, so you kind of like open it. That's kind of how I do it. If I have an assignment, I'll open it and I won't close it until it's done. So
Yeah, that's what I do.
yeah, so if it's still open, I know I still have to do it. So that's another good one. So we gotta do what we can, guys, because I can't go home with you and see if you're doing your homework. You guys have to be on it on your own and make sure that you're completing things on time. So do I have any last questions about that?
No.
Okie dokes. All right. So today we are going to be starting a brand new chapter from the book. So the past few weeks we've been doing equations, solving inequalities, solving literal equations, solving compound inequality, a lot of solving, right? We've been doing a lot of math. This chapter is a little interesting because there's a lot less math. There's a lot more interpreting graphs. So we're going to be looking at a lot of graphs. And what's nice for you about this chapter is that you guys are not going to have to write down a whole lot of stuff today, but I still need to make sure that you guys are paying attention and staying focused. So at this time, let's see, I only see 7 cameras on. Can we turn that 7 into something closer to 17
Miss,
or 19?
I'm trying to turn my camera on because I'm sick and I look so bad.
You look so bad. Do this. Can you do this? Look up.
Okay, Miss, I'll do that.
There you go. Now you guys only see my eyes.
Just show your forehead.
Just show your forehead. That's all I need. I just want to make sure that you're there, you know? That you guys are not ghosting out on me. Okay. That's much better. Thank you. Okay, so the reason I'm saying that is just because today there's a lot less like writing stuff down, so I just want to make sure you're here. Okay, so here's the first one. It does not want to load on me today. Hold on. Let me see what's going on. I feel my iPad keeps like disconnecting. So we're just going to be patient. Okay, it's loading. Sorry, y'all. I don't know why it's being difficult today. It's been doing so well, hasn't it? Like, we haven't had any problems for like a few weeks. There we go. Okay, you guys can see it now? Okay. All right,
Yeah.
cool. Hopefully it'll stay. Okay, so basically what we're going to be looking at today is a lot of graphs, and those graphs are going to be connected to a story. So we're going to see how can I read a story and then connect it to the graph and understand what the graph is saying. So there's going to be a couple of examples where you guys are going to be able to read. So can I have a volunteer for the first example? Who would like to read?
Can I read?
Go ahead, Elvis. Yeah.
Number one? Or eight?
Just the at the very top.
The distance a delivery van is from the warehouse varies throughout the day. The graph shows the distance from the warehouse for a day from 8 o'clock a.m. to 5 o'clock p.m.
Perfect. All right. So this is the information that we just read tells us what we're looking at on the graph, right? Now let's look at the graph and let's label our axes. Which one is the x-axis? The time or the distance?
Time.
Time.
Good. So remember, the bottom one is always going to be your x-axis, and the other one is your y-axis. And in this case, my y-axis is measuring the distance from where? Look back to the words.
The warehouse.
From the warehouse for a day.
Good.
Oh.
From the warehouse. You got it. So we're kind of looking at a graph of like where that car or that van is located throughout the day. So can someone tell me like generally what happens? Generally, what is this van doing? What does it mean? Like the graph goes up and then it kind of comes down. So what does that mean about the van?
How long it takes him to deliver it?
How long it takes him to deliver, and then not only how long, but what else? What is the van like actually doing?
The stops like he makes every time.
Okay, so it's making some stops, and it's going, is it going, well, you can see like it goes up and it comes back down. So it goes away from the warehouse, and then what happens?
Go back.
It comes back, exactly. So it goes away, it makes some stops, and then it comes back. So let's go ahead and answer these questions now. So for letter A, can I have a volunteer? There's going to be 4 questions, so starting with one volunteer for question A.
Segment 1 shows that the delivery van moved away from the warehouse. What does segment 2 show?
Okay. So looking at the difference between segment 1 and segment 2, what do you guys notice? What changes?
Miss, can I say something?
Mm-hmm.
I just want to let you know that I'm not gonna understand this lesson, because I'm not laughing gas right now, so I'm not gonna understand anything. So
Tyresha, what are you doing?
what am I doing? I just came from the dentist.
You came from the dentist? Okay, I'm gonna mute you. You're gonna stay on mute and you're gonna do your best to pay attention. Sound good?
Oh, chill.
Okay. All right, so somebody else, can y'all tell me what's the difference? What happens from segment 1 compared to segment 2?
I'm gonna say that it's shorter.
It's shorter. Okay, what else? That's good. That's one observation. What else do we see? Speak up, y'all. They're not the same. They're different. How are they different? Y'all are shy today. It's because there's no math anymore. Now you got to use your eyes.
Miss, I'm good with numbers, not like words and stuff like.
All right, well, let me help you guys out. So we know that, like Cassie said, the second segment is a little bit shorter. What's another word you can use to describe the blue segment? Is it, I don't know, like why are they different? What changes?
It's gonna take less time.
It's gonna take less time. Okay, yeah, that's one thing. Very good. So segment 2 lasts a little bit less time. Which one goes further?
Segment 1.
Segment 1 goes a little bit farther than segment 2. So notice how segment 1, let's think about, pretend this is a mountain. Which of those two segments is going to be easier to walk up? The purple one or the blue?
The blue one.
Blue one.
The
Yeah,
blue.
good. We agree. Blue is going to be easier. That's because segment 1, this is steeper. It's a harder hill. It's harder to walk up. So when something is steeper, especially if you're measuring like the distance and the time, when something is steeper, that's because it's going faster. So the purple one is faster than the blue one. So this van started off going pretty fast, and then after a little while, he had to slow down. Does that kind of make a little more sense now? Give me a little nod. I can see your heads.
Yes.
Yes, okay, cool. So segment 2, the van is still moving, it's still going somewhere, it's just going a little bit slower. So slows down. And you do not need to write this. Like I said, it's going to be a lot of just looking today, not a whole lot of writing. Okay, can I have a volunteer read letter B?
Based on the time frame, what change in the distance from the warehouse is represented by segment 6?
Okay, so what is happening now that didn't happen before at segment 6?
Going down.
It's going down. We've been going up, now we're coming back down. So what does that mean about the van?
It's going faster?
I hit that, and then I control.
Remember, it's not necessarily going faster. What is the y-axis measuring?
The hour.
The distance.
The distance. So if the distance was going up, 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 and now the distance is going down, where is the van in real life? What's happening with the van?
Going back to
Yeah, he's
City?
returning. You got it. The van is returning to the warehouse or wherever. Okay, letter C. Somebody read letter C.
Which line segments show intervals where the distance did not change?
Okay, so anyone can answer this. Where do you see that this distance is not changing?
Wait, what was the question?
Which line segments show that the intervals where the distance didn't change?
8 and 9.
8 and 9? What's happening in 8 and 9?
They're just going down.
It's going down. What's going down? The time or the distance?
The distance.
The distance.
The distance is going down. And remember what that means. What does it mean when the distance goes down? What does that represent about my van?
That is soon gonna stop.
Right. Remember that distance is how far I am from the warehouse. So if I start out at the warehouse, I get further and further and further because I'm going and I'm delivering my packages. At a certain time, remember what happened in number 6. At number 6, this is telling me that the van is returning. So 8 and 9 are still just showing me that the van it's on his way back. So it doesn't mean that he stopped, it just means that he's on his way back. But which intervals can tell me that the distance is not changing?
3 and 5.
There you go. 3, 5, and there's actually one more.
Oh, 7.
7. Good. So notice what's happening here. The line, the graph is flat. When the graph is flat, a flat line means there's no change. So segment 3, 5, and 7. And then finally, question D. Who can read D for us?
What is a possible explanation for these segments?
Okay, so based on what we know, what the scenario, what might be happening at segment 3, segment 5, and segment 7?
Miss, what was your question?
Exactly what she just read for letter D. What is it possible?
The van is getting slower.
Remember what it says. There's no change. So what does it mean if I'm driving a van and my distance is not changing? What does that mean about the van?
It's staying the same.
It's staying the same. So am I moving?
Maybe.
Yes.
No?
Yeah.
Yes.
Possibly, Miss.
Maybe.
There's only one right answer. There's no maybe. Am I moving?
Yeah.
No?
Yes.
Okay.
No.
Y'all need to visualize this. All right. We're gonna visualize.
Miss, I don't understand none of this.
Okay.
For
Okay.
real, miss, I'm lost.
All
For
right.
real, Miss.
All right. We're gonna play. Okay. Here we go. I have an AirPods case. This AirPod case is my van. At the beginning, what's happening with the van? What's it doing? Purple.
It's going up.
Okay, but is the van flying in the air?
Going
No.
up a hill.
No. What is the distance
Going
measuring?
fast.
It's moving. I don't know.
Somebody just said it. It's going fast. It's driving on. What am I driving on? Am I flying?
A road or something?
Yeah, I'm just driving on a road. That's all it is. So I'm driving on a road, and my distance from the warehouse, remember, the y-axis doesn't mean it's going up the hill. It's not on a hill. It just means it's going away from the warehouse. So if my warehouse is right here, let's see. Okay. This is my warehouse. This is my van. I'm going away, but I'm doing it fast. Right? So I'm driving on, am I going to be driving on a local road or a highway?
Highway.
Probably on a highway, right? So I start off, I'm on a highway. I go fast. Then I slow down. So maybe he got off the highway and now he's on a local road. Now I'm going a little slower. Then at number 3, what happens?
It stopped.
He stops, exactly. So at segment 3, segment 5, and segment 7, the van stopped. So why might he have stopped? Knowing what we know about this situation, what is he probably doing when he stops?
Delivery.
Yeah, exactly.
Oh.
You see, miss, we need a more explanation with pictures, miss. Because
Well-
we don't understand stuff.
Well, now I just made it make a little more sense. So there you go.
Well, at least me.
So let's review what's happening. So I'm gonna erase all of this, make it a little bit better. So at the beginning, when it's going upwards, that means he's going away. When it's going downwards, that tells me
It's
he's coming.
returning.
He's returning. And anytime that it's flat, so these 3, that's a delivery point. So see why it's a little tricky with these types of graphs. You have to read the problem very carefully, and you have to make sure you look at the X and the Y axis so that you know what it's measuring. We're gonna do a few more examples, and I promise it'll make more sense. Okay, so here's one. Can I have a volunteer read example 1?
Three hoses fill three different water barrels. A green hose fills a water barrel at a constant rate. A black hose is slowly open with filling the barrel. A blue hose is completely open at the beginning and then slowly closed. The three graphs of the situation are shown.
Perfect. All right. So we want to figure out which of these graphs matches to which color hose. So there's a green hose. There's a black hose. And there's a blue hose. Okay. So what we want to try and figure out is which one of these goes with which. So which of these, the green, black, or blue, kind of is the easiest to figure out right away?
B.
Okay. And what key word do you see that tells you?
Constant rate.
Good. Constant rate. Constant rate, you're going to see this word a lot. And it's important to remember that when something is constant on a graph, it's going to be a straight line. And in this case,
You don't write this, right?
no, like I said, not a lot of writing. I will tell you when there's a definition or something you do have to write. All right, so in this case, my answer choice B has a straight line, so I know that this one is green. The other two are a little harder to figure out, so we have to think about it a little bit more carefully. What I'm going to do is I'm going to start with letter A. And I'm going to kind of divide this graph into two separate parts. Because at first, my graph goes like this, and then it kind of takes a turn, and it goes like that. So take away the information you just read, but let's just think about visually looking at this graph. Which hill is harder to climb? The pink one or the purple one?
Pink one.
Pink, right? You better take out your hiking boots because it's going to be a hard hill to climb, okay? You're going to need to like literally rock climb it. Whereas the purple one, you can easily walk up that hill. So what does that mean? Which one is faster? Pink or purple?
C.
I'm just asking pink or purple, which one's faster?
Oh, purple.
Purple.
Other way around. Remember from the previous problem,
Green.
pink. Remember, when you have a really steep hill, that's telling, oops, what did I write? That's telling me that I'm going fast. When I have an easy hill to climb, that's telling me that it's going slow. So let's look at the answer choice C as a comparison. First, it starts out like that, and then it kind of changes, and it goes like this. Which hill is going to be steeper and harder to climb, the orange one or the red one?
The orange one.
The orange one. So is orange faster than red or slower than red?
Slower.
Is it harder to climb or easier to climb?
Harder.
Harder. So is it fast or is it slow?
Slow.
Y'all still have this backwards. This is fast.
Fast. Well, why if it's harder?
Because whenever you have a steep hill or a steep change, okay, on a graph, that tells you that whatever you're measuring is going fast. It's changing really fast. In this case, I'm measuring water. I'm measuring how much water is in the barrel, right? So in answer choice A, the amount of water starts slowly. It kind of starts filling slowly. And then all of a sudden, it's going to go really, really fast. Whereas in answer choice C, it starts out really fast. The water level goes up really, really fast. And then all of a sudden, it slows down. So that's my question is, which one is the black hose and which one is the blue hose?
The black hose is the purple and pink, and then the other one is the other one.
Good. Because the black hose slowly opens And then that's why when it's slowly opening, it means it starts out slow and then it's going to get fast. Whereas the blue is completely open. So when that hose is completely open, that water is going to go shoot out really, really fast. And then they're slowly closing it so it slows down. So this is going to be very, very important to remember. The steeper the hill, the faster it's going. No matter what you're measuring, the steeper it is, the faster it's going to go. So you always want to think about, is this hill going to be easy to climb or is it going to be really steep? Let's see if we understand this, and let's do, now this one you're going to try on your own. Can I have a volunteer read this one?
You and a friend are playing catch. You throw 3 different balls to your friend. You throw the first ball in an arch and your friend catches it. You throw the second ball in an arch, but this time the ball gets stuck in a tree. You throw the third ball directly at your friend, but it lands in front of your friend, then rolls the rest of the way on the ground. The 3 graphs describe this situation.
Perfect. All right. So what you guys have to figure out now is which of these represents ball number 1, which of them is ball number 2, and which of them is ball number 3. So I want you guys to think about it for 2 minutes. You can send me your answers, but then we'll go through it together. So which one's number 1? Which one is number 2? Which one is number 3?
Oh, Miss, I know.
Okay, send me your answers. About 30 seconds left.
Supposed to answer this?
So right now, I want you guys to tell me which one is which. So which graph corresponds to which ball? All right. So a few of you guys had some good answers. Now let's go through it together. So which of these is the one where you throw the ball and your friend catches it? So scenario number 1.
B.
B, good. Okay, it goes up in the air, it goes down, and then why doesn't it go down to the ground? Why does it kind of
Because your
stop?
friend catches it.
Right. You can kind of think like your friend is right here. He just catches the ball. Maybe he's wearing like a little baseball cap. I don't know. Okay.
Miss,
All
what
right.
a cute little stick figure. Your stick figure is cute.
Thank you. I'm an artist. All right. Which one is the second ball? It gets stuck in a tree.
D.
C. Good. How do we know it gets stuck in a tree? What did you guys
Because it
look
goes
for?
up and it stays up.
It stays up, exactly. So maybe what happened here was there was a tree, and the rest of the time it was just stuck in that tree. All right. And then the third one
It's A.
is A.
A.
It lands on the ground. And then your friend is over here and he's really sad because he can't can't catch the ball. All right, so any questions on this one? This one was a little bit easier because the y-axis was measuring height. So it looks more like a ball going up and a ball going down. That's why it's important to read what the axes are talking about, because sometimes it's height, sometimes it's not height, it's going to be something else. So any questions on this one?
No.
Okay. All right. Now try this one on your own. So I'm actually going to put a poll again so you guys can vote on the correct answer. So let me just pull that up. Okay. So when you've made your choice, go ahead and vote on it, and I'm going to put 2 minutes on the clock again. And while you guys are working on it, I'm going to read it out loud. So, Janelle alternates between running and walking. She begins by walking for a short period and then runs for the same amount of time. She takes a break before beginning to walk again. Consider the graphs shown. Which graph best represents the given situation? Okay, I have 10 votes so far, 10 out of 19 people. There's about 45 seconds remaining. Okay, 12, 13 votes. Three seconds, 2, 1. All right. So let's see what happened. Here are the results. The most popular answer was answer choice C, and that is, in fact, the correct answer. So good job if you voted for C. Nice job. 80% of you guys. So with C, let's just quickly go through what happens. So she does 4 things. What's the first thing she does?
She walks.
Walk. Is that going to be slow or fast?
Slow.
Slow. So are you looking for a steep hill or an easy hill?
Easy.
Easy, exactly. So some of you guys, you might have been stuck between answer choice B and answer choice D, but notice that the first segment over here is an easy hill, so that's how you know that this is going slow, whereas the second segment is a steeper hill, so you know that that's going to be a little bit faster because she's running. And remember what I said before is that whenever it's flat, what's happening when it's flat?
Stop.
That's a stop.
Is the same?
Her distance is the same. And if your distance isn't changing, that means you're not moving, right? So she's not moving. So that's why we have a stop there. And then in her last segment, it's very similar to the first one because it's going slowly. So you know she's back to walking. What do we call a straight line like answer choice A? What would this be?
They stop.
What was that key word though?
Constant.
Constant. This one's constant. And then what was missing from answer choice D?
The stopping.
Mm-hmm. There was no stopping here. So that is why these were all incorrect. Any questions on this one? Going once, going twice. Okay.
No.
Awesome, let's do another. Well, actually now, we're gonna talk about intervals and inequalities. So this is a little bit different, but we're still sort of looking at a similar situation. So let me go ahead and read this one. So a bathtub is being filled with water. After 10 minutes, there are 75 quarts of water in the tub. Then someone accidentally pulls the drain plug while the water's still running, and the tub begins to empty. The tub loses 15 quarts in 5 minutes. And then someone plugs the drain and the tub fills for 6 more minutes, gaining another 45 quarts of water. After a 15-minute bath, the person gets out and pulls the drain plug. It takes 11 minutes for the tub to drain. Okay, so this is pretty self-explanatory. The y-axis is telling me how much water is in the tub. So the amount of water goes up, and then it comes down a little bit, then it goes back up. And then what's happening here?
It stops.
It stops. And why did it stop? Look back at the problem. Why did the water level stay the same?
Because they plugged the thing in.
They plugged it, and what are they doing for 15 minutes?
They were filling up the tub.
But for those 15 minutes, what was happening
the
there?
bath.
That's the bath. That's bath time. Okay. So now I want to know during which interval is the water level decreasing. So I'm going to label them. During which intervals is the water level decreasing?
Increasing or decreasing?
Decreasing.
The 5.
5.
5.
There's another one.
Oh, the 2.
Oh,
And
2.
2, good. So 2 and 5. However, we're going to be writing this a very specific way because in algebra class, when I ask you what's the interval, I want to know what time you're talking about. So from when to when is number 2?
10 minutes.
It's 10 minutes long, but from what time to what time?
Oh, to 15.
Mm-hmm. So from 10 to 15. Same thing with number 5. Now you're gonna have to do a little bit of rereading because it's not as obvious. So look back, see if you can figure out what time is this at and what time are we ending at.
$37.
37, you're very close. It's not 37.
36.
It was 36, yeah. So let's go back and do the math. Number 2 ends at the 15. So it goes 10 minutes, then it goes 5 minutes.
41.
Then the next segment, so segment 3 goes for 3 minutes. Sorry, no, 6 minutes, sorry. So segment 3 finishes at what time? If that was 6 minutes.
26 minutes.
That would be at 20. Oh no, look back, it goes, so segment 3 starts at 15 minutes and runs for 6 minutes. So when does it end?
21.
21. Segment 4 goes for 15 minutes. It's a 15-minute bath. So when is the bath over? That's how you get 36, because we know that was 15 minutes long. And then the last segment takes 11 minutes. So how long does number 5 last? When do we finish?
41.
40, I heard someone else, 47, because we start at 36, 36 plus 11 gives me 47. Okay, so now I have all the blanks filled in. So from 1 to 1 is segment 5.
36 to 47.
36 to 47. And now I'm going to show you how to write this the mathematical way, because on your tests and things like that, you're not going to write it with words. It's going to look like this.
Yes, you wrote 37.
Oh, I'll fix it. So the segment number 2 looks like this. Segment number 5 looks like this. What is this to remind you of?
4.
No, they're the same. They combine, right?
Yeah, what are these called with those symbols?
Inequality.
Yeah, they're inequalities. So we use inequalities to show these intervals. So remember, these inequalities are literally telling you x is from, or x is between 36 and 47. It's just a mathematical way of saying the same thing. So I know it might look a little bit confusing. Let's do a couple more examples where it's going to make a little bit more sense.
Yeah, Miss, math is complicated.
It's not that hard. All right, when is the water level increasing? So now I'm not going to label it. Somebody out there tell me one interval where it is increasing from 1 to 1.
From 15 to 20.
From 15 to, so this was 15, and then that goes for 6 minutes. So it's not to 20. It's going to
21.
be to 21. That's one interval where it's increasing. What's another one?
In the beginning.
To 0 to like.
Yeah.
Like 12, I think it says.
Look carefully. A bathtub is being filled with water after
Till 10.
10 minutes. Yeah, 0 to 10. Okay, so those are my 2 intervals. Is it increasing anywhere else?
No.
No, it stays the same and then decreases.
Yeah, it's doing different things in the other places. So let me write my inequality for the first one. I'm going to write 15 less than x less than 21. That's all. It's the same. It's always going to look like that.
This is always going to do it that way.
Yep, exactly like that. So what should I write for my second one?
0.
0 less than x, 10 less than x.
Less than 10, like that. That's it. It's a little, like, just annoying that you have to do it this way maybe, but at the end of the day, it's always going to look like this, so that won't confuse you. They're not going to make it look any different. Do I have any questions on how I wrote the inequality or how I found it on the graph?
No.
Okay, let's do one more. Now I want to know, during which interval does the water level remain the same? So where am I looking on my graph?
Where it has a straight line.
Oh, like 25. I'm 25.
Okay, so I heard straight line. All of these lines are straight. It's just that this one is flat. So a good word to use is flat line. So this flat line is showing me where it's staying the same. And do you guys remember what numbers this was from 1 to 1?
21.
Oh, it says 15 minutes after it stays there for 15 minutes.
So if I start at 21, when does he end the bath?
36.
30,
Oh, 37. No, 36.
36. Yeah. After his 15-minute bath. Okay, so what's my interval? Somebody give me the whole thing.
Oh, 21 less than X, 36 less than 36.
Perfect. That's it. So it's just the mathematical way of writing it. That's all. It's not like you have to like do any math with it. It's just a
Miss, this is
statement.
kind of easy. All you gotta do is read.
Yeah, see? It's not that hard. Okay, next up, we just have some keywords. So this is the only thing I really do want you to write down. So I'm gonna give you guys 2 minutes to write this down. These are keywords that are gonna come up for the rest of your life. So you better know what they mean. 2 minutes, go ahead and write it down.
Write these words down.
Yes, all of these 3 keywords and their definition. "30 seconds remaining, but if you're not done after that, it's okay." Okay, so if you're not done writing, that's okay, because I'm going to take a little time to label this graph and show you where these things are located. So when I say x-intercept, I'm looking for the place on the graph where your graph touches the x-axis. So you're looking at the place where it's either touching the x-axis or it's crossing the x-axis. And in this case, my graph is touching the x-axis right down here. What point is that at? What number is that at?
5.5.
Oh, the bottom part.
5.5.
Yeah.
So this point is 5.5 comma 0 because it's on the x-axis, so the y-coordinate is 0. And that's what's super important about these types of points. The x-intercept is where y equals 0, and then the y-intercept is the opposite. So on my graph, the y-intercept
48, right?
yeah, is at 0, comma 48, where x is 0. Now remember, coordinate points, they go x comma y.
If the X is ends like at 16, would it be 5.516?
5.516, where do you see a 16?
No, but
Oh,
let's say like the dot ends like at a 16 at a certain number other than 0.
well, the 16 is over here. That's still higher up. That would be this point right there. The green point is located on the x-axis, so that's how I know that y equals 0. Because you're always looking at what line is it on. Any questions on finding the x-intercept or finding the y-intercept? Okay. Now the maximum or minimum is always going to be like the peak of the mountain. Okay, so you're always, if it's shaped kind of like a mountain, you're looking for the top point. And if it's going the other way, you're looking for the bottom point. Now in this case, do I have a maximum or do I have a minimum? Yeah, a maximum, because I have a mountain, it's going up and it's going back down. So I'm looking at the tippity top. And what coordinate point is that maximum located at?
144.3.
2.5.
So 2.5, good. So I'm looking down right here. I'm at 2.5, comma what?
144.
140, like a little bit higher than 144, so I'll say 145. So that's what I have for my y-intercept, my x-intercept, and my maximum. Do I have any questions on what these look like or why I put them where they are?
Wait, Miss, what if you can't really tell where like the dot will end? Like right now that you said was probably like 145.
If I'm asking you to estimate, I'll tell you. So in this case, you would have to estimate. Otherwise, you would always you will know exactly where it is.
Yeah, but what if it's in like a state test or something like that?
Then look at your answer choices and pick the best one. So if the answer choices were 13, 45, 145, and 500, there's only one that's going to be the right choice.
Oh, okay.
Alrighty. So now I want you guys to do it for this one. It's a little bit, I'm sorry, it's a little bit blurry, but do your best to estimate where is the x-intercept, where is the y-intercept, and try and see if there is a maximum or a minimum. I want you guys to just think about it for 30 more seconds and then we'll go over it.
Did you want us to write it in the chat?
No, because we're gonna just do it together. Okay, so that 30 seconds is up. Now I would just like 3 volunteers. So who would like to go first for x-intercept? Where is it?
Me. 15.
Go for it. 15. Good. 15, but remember we're gonna use the whole coordinate point, so that's gonna be 15, comma
0.
0. Good. How about my y-intercept? Who would like to give me that? Daniela.
25.
25. Good. And in this case, is it 25, comma 0 or 0, comma 25?
0.
0.25.
Good. All right, and then this was a little bit tricky, so I want to hear what you guys want to say. Is there a maximum?
Why did you put 0 if the thing doesn't start at 0?
Yeah, there is a maximum.
Okay, let me go back and answer Melanie's question real quick. Why did I put 0? Because remember, your coordinate point, when you write a point, is x, comma y, right? And I'm on the y-axis. So for this blue point, I didn't go to the left or to the right. I stayed at the middle, and then I went up to the 25. So that's why the x value is a 0. Same thing with the x-intercept. This is 15 comma 0 because I went 15 to the right, but then it doesn't go up or down. It just stays on the x-axis.
Okay, miss.
Okay, so now what about the maximum? So I think Ascanio said yes, there's a maximum.
Would it be 10:45? 10 comma 45?
No,
Right here?
it's 5:45. Wouldn't it be 5:45?
That's the question. The answer is you're both right, because the maximum is not just 1 point. How many points is it?
The highest place.
The highest place. Well, everything on this line is at the same height. So the maximum is actually that whole section.
So it would be 5:45. How would it work?
So you can make it an interval. So between 5 and 10, how would you write that as an interval?
5?
5. Remember what we were doing just before. How would I write that as an inequality?
Less than x.
5 less than x less than 10.
There you go. That's it. So from 5 to 10.
Why not the 45?
Good question. So you could also, that's actually two ways to write it. So you could say the x values are from 5 to 10, and the y value stays the same at 45. On a test, they would always specify which one they want you to write down. So they would probably say, like, what is the y value of the maximum? But in this case, I didn't specify. So you could put either one. Okay. So that's that on that. Now I have, perfect. We have enough time. We're going to do like 5 or 6 test questions, and I'm going to use the poll feature for all of them. So we're going to do another one where you're going to vote on it, and then we'll discuss it together. So here's number 1. I want you guys to go ahead and read it carefully, look at those answer choices. This is a good example because it has a lot of words, and you try to figure out what words matter and what words are you not going to pay attention to.
No, absolutely nothing.
Try your best.
All right.
I'm going to put 2 minutes on the clock.
You think you're not smart like that, miss.
You are. 2 minutes on the clock. I already have one answer choice, one vote.
I tried.
10 votes are in. There's still a minute left, so you can take your time if you're still not sure. Good, I have 13 votes out of 19 students, so if you still haven't voted, you have 15 seconds left. All right, 5, 4, 3, put anything in, 2, and 1. All right, this was very interesting for me to look at. Let's look at what happened. So this doesn't mean that D was the right choice. It's just showing you that between C and D, we were kind of split up. So let's read this now. Like I said, they put a lot of words in there, and most of them don't even matter. Would anyone like to read from the very top?
Miss, I got a question.
Mm-hmm.
But 350 is like the point, so it doesn't really have space to move in.
Say that one more
So
time.
so like 350 is on the top of the height, and
Mhm.
25 has like more space to move in, so it's like at the bottom. Because that's
Okay.
like more like a triangle.
You're overthinking it. Let's read it. It'll make more sense when we read it. Okay, so let's go ahead and read from the top. Who would like to read? Who would like to read at the top?
I'll read.
Go ahead.
Oh, whatever, just go.
The graph models the area in square feet of a rectangular porch with a length that is 0.56 W less than 28 feet, given a width of W feet.
Okay, and then read the actual question.
Based on the graph, what is the width in feet of the porch? What is the greatest area?
Okay, guess what, guys? All of that stuff at the very top, none of that matters. None of that matters because we have a graph in front of us, so we can use our eyes. We don't need to be reading all those words and getting confused and nothing makes sense. This part, the second part, is the actual question, and that's the part that actually matters. So I'm going to read that question one more time. Based on the graph, what is the width in feet of the porch with the greatest area? So what is it asking me? What is the actual question?
What is the width?
What is the width? So I want to know, based on this graph, what is the width when it's at the greatest area? So what is that point, that tippity top? What do I call that?
Oh, it's pretty much what's at the top is the answer.
So what's
So it's
that? What's that tippity top called?
The highest point.
It has a name. It has a name that starts with M.
Maximum.
Maximum.
I see.
So it's asking me.
Got that right. I thought I was wrong. I said maximum.
So it's asking me what is the width at the maximum. Now look at your maximum. That maximum has 2 points. It has a 25, comma 350. Which of those is the width?
350? Oh, 25. Oh, no.
Which is the width? Look at your axis. Read the words.
25.
25 is the width. So the answer was C. A lot of people put D because they looked at the maximum, they looked at the top point, and they read, oh, that's at the 350. Okay. But that's not what the width is. That's what the area is.
Wait, miss, I said 25 and you didn't listen.
I heard you. I was just,
Yes,
I wanted to create some drama.
The greatest area.
So, okay, so the greatest area is 350. The area is 350, and the width is 25. That one was tricky. So, but do you guys see how, like, the concept is easy? Like, you can look at a graph and see the tippity top. That's easy. It's reading that's the hard part. So we're going to be doing a lot of questions like this because we got to practice reading these problems and understanding what they're saying. Let's do another one. This one's a little bit easier, but try your best. Read it carefully, choose your answer, 2 minutes on the clock. Okay, 1 minute left. And right now, y'all, it is completely split between A, B, C, and D. So who's going to win? Which one is it? 45 more seconds. Okay, I have 13 votes out of 18 students. 20 seconds remaining. If you're not sure, just pick one and guess. 10 seconds remaining. 5, 4, pick a number. 3, 2, and 1. Okay, let's look at what happened. This one was super interesting. So we were pretty split between A and D. So let's read this again, or let's read this for the first time. The graph below represents a jogger's speed during her 20-minute jog around the neighborhood. Okay, so she's jogging, and the line tells me the speed, or the y-axis is giving me her speed, and that's going to be super important to analyze. So it's telling me her speed. So I'm looking between 9 and 12. So that means I'm looking
I just realized.
at this flat line right here. This is a trick I'm not even kidding, guys. This is a trick question. Remember what I said at the very beginning, right? I was like, okay, if it's a flat line, it probably means that they're doing what?
Constant, it stays the same.
It stays the same, right? Remember, at 9, what's her speed right here? What's her speed?
Oh.
6 miles per hour.
She's going at 6 miles per hour. Is she stopping or is she still running?
Still running.
She's still running. She's going at 6 miles per hour. How fast is she going here?
6 miles per hour.
6 miles per hour. Did anything change?
No, it was kept the same.
Stayed the same. What did she stop running?
No.
Exactly. She didn't stop running. Her speed stayed the same. So which answer choice is it?
D, miss.
It's D. She's not standing still. That's why it's so important to read the graph and understand what it's saying. Okay, when does she finally stop? At what point is she standing still? There's only 2 places where she's standing still.
In the beginning and at the end.
Yeah, the beginning and the end. That's when she's standing still. All the other times, she's running at different speeds. So this one was definitely very tricky. My first period had a hard time with this one. So does anyone have any questions about this one? But it was good to see that it was 50-50 between A and D, because I knew that that would be the 2 like most popular answers. Okay. Here's another. This one's the easiest one yet. I bet everybody will get this right. Here we go. Go ahead and get started. 2 minutes on the clock.
I have no idea what this is.
Remember that sometimes none of the words matter. Sometimes you just gotta use your eyes. About 30 seconds left. I'm still missing 10 votes. Good, 15 out of 18 have responded. I'm waiting on 3 more. Y'all got 5, 4, 3, 2, and 1. Okay. Nice job on this one, guys. Most people got this one right. There were a few incorrect answers, but since I have 10 people who got it right, can I have one volunteer give me a reason why C is the correct answer?
Because when you go to 2.5 and the rest down, it's always going to go down.
Good. So this is 2.5. And this is the ending point, 5.5. And during that time, the ball was going down. It went up and then it went down. Any final questions on this graph or this type of topic? Because we're almost done. Okay. Alrighty, so this is for next time. But tomorrow, I'm actually going to be absent tomorrow, okay? So I want everyone to listen very, very carefully to these instructions. Here we go. There's going to be 2 assignments to complete while I'm gone. The first one's on Khan Academy. It is already up. That one's already up, so you can do it tonight if you feel like it. The other one is on another website called Desmos. It's not gonna, you're just literally gonna, I'm gonna give you a link on Microsoft Teams and you'll have to click on that link and that's how you do the assignment. So all of this will be posted on Microsoft Teams. The most important thing though is that everything is due by 4 p.m. because the idea is you're supposed to do it during class. So you're supposed to do it from 2:30 to 4. So it's going to be due at 4 p.m. and I'm not going to accept any late assignments. Do I have any questions?
I was supposed to be doing midnight like normal assignments.
Nope, because you're supposed to do it during class time. It's not a homework assignment, it's an in-class assignment. So do I have any questions on that?
No.
Can I do it right now?
You can do the Khan Academy right now if you wish, if you feel like it. But otherwise, you're going to do it during class time. Any questions?
No.
All right, y'all. You can go. Have a good rest of your days. I won't see you tomorrow, but I'll see you on Thursday.
You won't be here tomorrow?
No.
I'm Miss Lopez.
Bye, guys.
Bye, Miss Lopez.
Miss you, miss.
I'll miss you too.
Bye.
Bye, guys. Bye.